Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into the fascinating world of Linux network programming, specifically socket programming. Think of it as plumbing for the internet, but way cooler. Way cooler.
I'm all ears. So, sockets? Are they like little containers for data packets zooming across the network? Because that sounds amazing.
Kind of. Think of them more as endpoints for communication, like doors between processes. They handle the sending and receiving of data, whether those processes are on the same machine or continents apart. The real magic is in the different types. We've got stream sockets, which are like a reliable river of data using TCP, and datagram sockets, which are more like throwing packets with UDP, less reliable, but much faster.
A river of data. I like that. So TCP is the reliable one, and UDP is the fast, reckless one? What about addressing? How do these packets know where to go?
Excellent question. In the internet domain, each socket gets a unique address, an IP address, think of it like a street address, and a port number, like the house number. The IP address identifies the device, and the port number specifies the application or service. It's all very organized, mostly.
Mostly? Uh-oh. What's the mostly about?
Well, there are some quirks. Ports under 1024 are considered privileged, requiring special permissions. And then there's the whole byte order thing, big endian versus little endian. It's a whole other can of worms. But thankfully, functions like !HTONL, and !HTONS, handle that conversion for us. Otherwise, we'd be sending gibberish across the network. Imagine the chaos.
Gibberish. Chaos. I see. So, we have these sockets, we know their addresses, but how do we actually use them? Are there special functions?
Absolutely. The BSD socket API gives us a whole toolbox of functions. !socket, !creates the socket, !bind, !assigns it an address, !listen, and !accept, handle incoming connections for servers, !connect, initiates connections for clients, send, and recv, send and receive data, and finally, close, closes the socket when you're done. It's like a well-orchestrated dance of functions.
A dance! I love it. So, this GitHub repo you mentioned, .it, covers all of this in detail, right? With examples?
Precisely. It's a comprehensive guide, walking you through building simple HTTP clients and servers, TCP and UDP-based client-server applications, even multi-threaded servers for handling multiple clients concurrently. It even delves into advanced techniques like non-blocking sockets and I/O multiplexing with select, and poll, which are crucial for building high-performance applications. And if you're feeling adventurous, there's even a section on broadcasting messages.
Wow, that's quite a journey. And it also mentions using libraries like libcurl and OpenSSL, right? To make things easier?
You got it! libcurl simplifies HTTP requests, making it much easier than dealing with sockets directly. And OpenSSL handles the secure communication aspects, ensuring your data is encrypted and protected. It's all about choosing the right tool for the job.
So if I want to build a secure, high-performance, multi-client server, this repo is my new best friend? I think I'm in love.
I think so too. It's a fantastic resource for anyone wanting to master Linux network programming. It's not just theory, it's packed with practical examples and clear explanations. Remember though, even with these tools, debugging network issues can still be a wild ride. But hey, that's half the fun, right?
Debugging, a wild ride. I'm ready for it. Thanks for the awesome summary. This has been incredibly insightful.
My pleasure. And to our listeners, thanks for tuning in to Tech Bytes and News. Until next time, keep those packets flowing. Goodbye.
Bye-bye.